In this section, I will show you how to secure your distributed applications by building secure and trusted Docker images, dealing with sensitive data and using various secrets in development. In the first video of the section, we are going to explore what sensitive data is and how we should deal with it in a mission-critical distributed application. These days, security in IT is a very hot topic. Cyber warfare is at an all-time high. Most high-profile companies have been victims of hacker attacks with very costly consequences. One of the worst nightmares of each chief information officer or chief technology officer is to wake up in the morning and hear in the news that their company has become a victim of a hacker attack and that sensitive information has been stolen or compromised. To counter most of the security threats mentioned, we need to establish a secure software supply chain and enforce security defense in depth. What is sensitive data and how does this really affect us developers and operations engineers? Well, let's look at some of the more common pieces of confidential data. First, we have things such as username password to access secured services. We have access key and access key secrets that are often used to access a protected API. We have such things as certificates used for secured and encrypted communication between different parties, to just name a few. Furthermore, privacy regulations such as GDPR, which stands for General Data Protection Regulation, and HIPAA, the Health Insurance Portability and Accountability Act, require us to keep our systems secure and the data they manipulate confidential. To establish this secure software supply chain, we need to have the following building blocks in place. First, secure communication and cryptographic node identity. First and foremost, we want to make sure that our cluster managed by the orchestrator is secure. Only trusted nodes can join the cluster. Each node that joins the cluster gets a cryptographic node identity, and all communications between the nodes must be encrypted. The second one is secure networks and network policies. When running application services, not every service needs to communicate with every other service in the cluster. Thus, we want the ability to sandbox services from each other and only run those services in the same networking sandbox that absolutely need to communicate with each other. All other services and all network traffic coming from outside of the cluster should have no possibility of accessing the sandboxed services. Third one is role-based access control, also called RBAC. One of the most important tasks next to security is to provide role-based access to the cluster and its resources. RBAC defines how subjects, users or groups of users of the system organized into teams and so on can access and manipulate the system. It makes sure that unauthorized personnel cannot do any harm to the system nor see any resources available in the system they are not supposed to know or see. And now to the secrets. These days, container orchestrators such as Kubernetes offer what's called secrets to deal with sensitive information in a highly secure way. And finally, content trust. For added security, we want to make sure that only trusted images run in our production cluster. Some container orchestrators allow us to configure a cluster so that it can only ever run signed images.